Hi all, we will explore the basics of statistics in a simple and practical way. In this video, let us begin with an important concept in statistics, measures of central tendency. By the end, you will be able to calculate and interpret measures of central tendency. Biostatistics helps us analyze and understand biological and medical data. One important concept in biostatistics is measures of central tendency, which helps us to represent a large set of observation with a single value. This representative value makes the data easier to understand, compare, and interpret. The three common measures of central tendency are mean, median, and mode. The arithmetic mean is the average of all the observations. The median is the middle value when the data are arranged in order. The mode is the value that occurs most frequently. Also, the two special averages are geometric mean and harmonic mean. The geometric mean is the nth root of the product of all the observations and is useful for growth related data. The harmonic mean is the reciprocal of the arithmetic mean of the reciprocals and is mainly used for averaging rates and ratios. The formula for finding the arithmetic mean depends on the type of the data we have. For raw data, we simply add all the observations and divide by the total number of observations. For all discrete frequency distribution, we multiply each value by its frequency, add the products and divide by the total frequency. For grouped or continuous data, we first find the midpoint of each class interval, multiply by its corresponding frequency, then we add all the products and then divide by the total frequency. In all the three cases, the aim is the same, to find the average value of the data. Now that we know the formulas, let us understand how to apply them by solving examples step by step. Let us now learn how to calculate the arithmetic mean for a discrete frequency distribution. In this example, the first row shows the observations xi and the second row shows how many times each observation occurs, called the frequency fi. The steps are as follows. In the first step, let us make a frequency table. In the first column, we will enter the given values xi. In the second column, we will enter the given frequencies fi and we find the sum of the frequencies, which is represented by capital letter N. In the next step, we will multiply xi with the corresponding frequencies fi and then we find the sum of the product of xi and fi. Finally, we use the mean formula x bar is equal to summation xi fi whole divided by summation fi to find the arithmetic mean of the given data. Let us now complete the calculation together by filling the table, one column at a time, and then we will find the mean. So the first column, we will enter the xi values and their corresponding frequencies in the second column. In the third column, we multiply each observation xi by its corresponding frequencies fi. And that is the first value, 1 into 5 will give you the product as 5. Similarly, we will find the product of each and every observations. Next, we calculate the totals. The total frequency of the second column is equal to 73 and the product XIFI is 299. Now using the formula, we will be having the arithmetic mean value as 299 divided by 73 is equal to 4.09. Now let us calculate the arithmetic mean for the grouped or a continuous data. Here the data are given in the form of class interval instead of individual values. First we write the class intervals and their corresponding frequencies. Next we calculate the midpoint of each class interval using the formula lower limit plus upper limit whole divided by 2. Then we multiply this xi with the corresponding frequencies fi and we find the sum of summation xi fi. Finally, we apply the formula, the same formula, x bar is equal to summation xi fi divided by summation fi. The only difference between the continuous frequency distribution and discrete frequency distribution is, here in continuous frequency distribution, the midpoints of the class intervals are treated as xi. Now let us complete the calculation of the mean of the grouped data. We first find the midpoint of each of the class interval, that is given by xi. So the midpoint of the class interval 0 to 10 will be 0 plus 10 divided by 2, it is equal to 5. Similarly, 10 plus 20 divided by 2 will be 15. Likewise, we calculate the midpoint of each of the class intervals and then we multiply xi with the corresponding fi value. Then we find the total. Sum of the frequencies fi is equal to 100 and sum of the frequencies of the product of xi fi is 2800. Now use the formula x bar is equal to summation xi fi by summation fi is equal to 2800 divided by 100 is equal to 28. So that is the corresponding mean. So far we have learnt the arithmetic mean. Now let us study two other important measures of central tendency, the geometric mean and the harmonic mean. Although they are not used frequently, as a geometric mean is mainly used for growth rates, percentage and ratios such as speed, time and efficiency. For any set of positive observations, the three means always satisfy uh, a relationship. Now the geometric mean is given by the nth root of the product of n positive observations. For n observations x1, x2, etc. xn, the geometric mean is given by the nth root of product of them. Or otherwise, we can write it as x1 into x2 into xn whole to the power of 1 by n. Only harmonic mean is given by the reciprocal of the arithmetic mean of the reciprocals of the observations. For n observations x1, x2, etc. xn, the harmonic mean is given by n divided by the reciprocals of the sum of the reciprocals of the corresponding observations. And the relationship between arithmetic mean, geometric mean and harmonic mean is, arithmetic mean is always greater than, the geometric mean is always greater than the harmonic mean. Let us now solve some examples for geometric mean and harmonic mean for raw data. First, we will calculate the geometric mean for 6 observations, 2, 3, 4, 6, and 6, 8, and 12. We multiply all the observations together and then we take the sixth root since we are having 6 observation. So the geometric mean is approximately 4.90. Now let us see an example for an harmonic mean. Find the harmonic mean for 20, 24, 30, 40, 60 and 120. Using the formula, Hm is equal to n divided by the sum of the reciprocals of the observation. We have 6 divided by, we will sum up the reciprocals of each of the individual observations. And then we get the geometric mean as harmonic mean as 34.29. So this slide summarizes the formulas used to calculate the geometric mean for different types of data. For raw data, we can either multiply all the observations and take the nth root, or otherwise even we can use a logarithmic method, which is easier when there are many observations. A geometric mean is equal to anti-log of summation log xi whole divided by n. For discrete frequency distribution, we raise each observation to its corresponding frequency and then take the root based on the total frequency. Again, the logarithm method is preferred because it simplifies the calculation. That is, geometric mean is equal to anti-log of the product of log xi with the corresponding frequencies and its summation whole divided by the sum of the frequencies. For continuous frequency distribution, we first calculate the midpoint of each class interval, then apply the same logarithm formula using the midpoints. Let us now calculate the geometric mean for a discrete frequency distribution. The observations are given along with their frequencies. Instead of multiplying all the values directly, we use the logarithmic method because it is simpler and faster. First, we write the observations and their frequencies in the first and the second column. Next, we find the logarithms of each of the xi's. And then in the next step, we will multiply the corresponding frequencies with the log xi value, and we find the sum of the product. And then we apply the formula Gm is equal to antilog of summation fi into log xi whole divided by summation fi. Now let us complete the calculation of the geometric mean. We first calculate the logarithms of each of the xi values. Here the xi values are 2, 4, 8 and 16. So the corresponding logarithmic values is log 2 to the base 10 will be 0.3010. Log 4 to the base 10 will be 0.6021. Similarly, we find the log value for the remaining observations. Then we will multiply the corresponding fi with that one. Then we calculate the sum of the frequencies. It is equal to 10, and then sum of the product of fi with the log xi will be getting the total as 6.9237. Now we use the formula. So the geometric mean is equal to antilog of 6.9237 divided by 10, which is equal to antilog of 0.69237, which is equal to 4.93. Let us now calculate the geometric mean for continuous or grouped frequency distribution. Since the data are given in class intervals, we cannot use the class intervals directly. First, we calculate the midpoint of each of the class interval. Next, we find the logarithm of each of the midpoint. Then we multiply each logarithm by its corresponding frequency, and then we calculate the geometric mean. Now let us complete the calculation of the geometric mean for the group T data. We first find the midpoint of each of the class intervals. For the class interval 10 to 20, the midpoint will be 10 plus 20 divided by 2, it is equal to 15. And then similarly 20 plus 30 divided by 2, that is 50 by 2 is equal to 25. Then we find the logarithmic values of each of the midpoints, like log 15 to the base 10 is 1.1761 and log 25 to the base 10 will be 1.3979. Then we multiply each of the logarithmic xi with the corresponding the frequencies. 4 into 1.1761 will be equal to 4.7044, and we will find the sum of the product of fi with the corresponding logarithmic terms of the observations. Now the total frequency is 30. Now we use the formula geometric mean is equal to antilog of summation fi into log xi divided by summation fi. It is antilog of 44.7286 divided by 30. That is antilog of 1.49095, which is equal to 30.98. Now let us learn the formula for the harmonic mean. The formula depends on the type of the data. For raw data, we already know that we divide the number of observation by the sum of the reciprocals of the observation. For a discrete frequency distribution, we divide the total frequency by sum of the frequencies divided by the corresponding observations. For a continuous frequency distribution, we first find the midpoint of each class interval and then apply the same formula using the midpoints. Now, let us calculate the harmonic mean for a continuous or a grouped frequency distribution. Since the data are given as class intervals, we will find the midpoints of each of the class interval. Next, we find the reciprocals of each midpoint. Then we multiply each reciprocal by its corresponding frequency and calculate the totals. Finally, we apply the harmonic mean formula to obtain the answer. Now let us complete the calculation of the harmonic mean for the grouped data. We first found the midpoint of each of the class interval, and then we will find the reciprocals of the midpoints. Like 1 by 15 is equal to 0.0667, 1 by 25 is equal to 0.04. Then we multiply the corresponding frequencies with the reciprocals of the observations. And now find the sum of the frequencies, it is equal to 30. And then we find the sum of the product of Fi with the reciprocals of the observations. The total is coming as 1.0421. Finally, we substitute these in the harmonic mean formula and we'll be getting the answer as 30 divided by 1.0421 is equal to 28 by 28.79. So the reference is I've used is Gupta SC and Kapoor VK, Fundamentals of Mathematical Statistics. Thank you everyone for your active participation. I hope today's session has given you a clear understanding of arithmetic mean, geometric mean and harmonic mean. In our next session, we will continue our discussion on measures of central tendency by learning about the median and mode with simple examples. Thank you.